All right, boys and girls. This activity is kind of the culmination or the stay-at-home lab. We would do it in class actually anyway. So I'm on, if you can see up here, question 1 of 19. Some of these we haven't covered directly, some of them we have, such as isotopes and ions in this general Edulastic assessment. So let's just do what it says, part 1, subatomic particles. So now we're going smaller than the atom. Open the website. So you're going to click there. You'll get this website. You're like, what? Go back. Now it says, click the start button to start the simulation. Click on the atom simulation. And we're showing you right here, because you can do the symbol and the game, but you can also come back and do, or go to this website. You don't have to click through Edulastic to get here. Once you have the site open, you can do whatever you'd like, really. But for this assessment, I want you to click on Atom. Okay, explore the atom simulation by dragging protons, neutrons, and electrons, which at this point you ought to know what they are. Neutrons and protons are in the center. Electrons orbit around them really fast, negative charged. So you click on the plus for each of the boxes, the element, the net charge, the mass number. It's going to give you the properties to view the changes as you change the number. So you're going to click on something and watch how it changes. You will click and see what happens. This is just an exploration. So which particles are found at the center of the atom? Check all that apply. So at the center, so if you're not sure, and I think you are by now, so let me go ahead and click on Build an Atom. Whoop. PhET Interactive Simulations. Atom, yes. So if I try to put a neutron out here, it doesn't let me. Okay. Let's try the middle. Oh, it did. So neutrons must be in the middle. And the way I'm doing this is you click down on it and you hold the click and drag it over. I'll put the proton right here. Silly goose. Protons don't go out there. Oh, that's where they belong. And look what I just made. It tells me my one proton and one neutron makes a hydrogen. And here's my periodic table up here in the right corner, and there's my H. This is where hydrogen is located. And I notice I have this plus ion. That means it's a positively charged. So net charge, I'm going to go ahead and click on this plus sign, and that drops down this. I'm going to click on mass number, and that drops on that. So my mass number is 2, meaning it weighs 2 mass units. And my net charge looks like it's positive 1. That means I have 1 proton. So this is a hydrogen ion. Well, I still have one more. How about electrons? Try that in the middle. Nope. Oh yeah, electrons are outside. All right, so now I have a neutral atom. And this is, for the most part, what I want you to produce, neutral atoms. So hydrogen is 1 proton, 1 neutron in the nucleus, and 1 electron. And I see that I have a net charge of 0, which is as it should be in the beginning. Ions are not bad, but just to make the simple atom, you want it to have a balanced charge. Remember, electrons equal protons, so we should have 1 of each. The mass number is still 2. Now we added an electron. Why is that? Why is it still only 2? Well, because electrons practically have no weight compared to protons and neutrons. Understand that this little blue ball is actually a lot smaller than that compared to these two. And so there you are. What if I added another proton? Oh, well, 2 protons makes it a helium ion. And now we're over here at the He. So the number of protons looks like it defines what element it is. So, lithium, okay, beryllium. And every time I add one of these, I'm going right down the chart. Well, that's interesting. I'm going to start putting it back now. So you get the idea. I just want you to play with these numbers and see what happens over here as the charge goes up and down depending on what you add to it. So here I made a neutral again. So this is good. What is it? Helium. 2 protons, 2 electrons, which makes sense because it's supposed to be the same number of protons and electrons. Electrons are out here in the orbital. I can also view this in clouds if I wanted, but I don't want. There we go. Mass number 3. Why? Oh yeah, we have another proton. 1, 2, 3. Neutrons have a mass, they have a weight, but they don't have any charge, which is why they're not affecting anything. See, when I add this one, the mass number goes up, but the charge did not. So there's my perfect helium atom right there. Okay, so you go ahead and do this on your own and just play around, see what happens, and answer the questions as you go. Okay, so here we are. Which particles are found in the center? We now know those red ones were protons, the gray ones were neutrons. These didn't stay in the middle. And I'm going to go to the next question. Keep adding and subtracting particles until you discover which particle determines the name of the element that you build. Oh, we found that out right away, remember? I added another proton and it changed from hydrogen to helium. You get the idea. Use the simulation to create the following atom. So go back and play with it. Do atom with 3 protons and 4 neutrons and see what name it gives you. 2 and 4, see what name it gives you. Type it in. 4 protons and 4 neutrons, see what name. See what you learn by doing this. Okay, so the neutron number stays the same in each of these, but the proton number changes in each of these. And let's see how that affects the name of the element. Play with the simulation. Which particles affect the charge? All right, so that's all there is to this. I really just want you to get the idea of we're learning about the structure of atoms, and we're learning about where protons, neutrons, and electrons are in the atom, and how protons, neutrons, and electrons affect the charge and the weight of the atom. So there's the name, there's the charge, and there's the weight. And it's all influenced by these 3 subatomic particles. If you need to, rewind this and hear me say all that again. Okay? And as you play, you just click back and forth answering these questions as you go through. Practice applying your understanding once you do by playing the first and second games on the game screen until you get 5 stars on each. So now choose your game. I would choose one of these 2. So go over here and you're going to play a game. So reload, that starts everything. Actually, you might have to go back to the website to play the game. Oh, it's down here. See all the way down here, electrons, game. And click these. So there's that one, challenge 1 of 5. If you want to play a different game then, so it says find the element. So I'm going to look at this atom and I see there's 2 protons. Because I learned earlier that proton is what changed the name. So I had 1, 2. Boy, you're really going to have to know your periodic table, huh? So this is what I'm going to do. Is it neutral or an ion? What was an ion? Oh, yeah. That's the charged particle. That's if we have not enough electrons. But I have the same number of positive protons and electrons. So it should not be an ion. That should be neutral. Let's check. Hey, I'm right. So don't be afraid to explore. And do it says next. Just kind of spend some time getting to know it a little bit. And then play the other game. So let's go to the other game and I'll show you that one real quick. I'm going to put start over. This one. What is the mass number? So I look at this element over here. I don't see any electrons, but that doesn't matter, I guess, because electrons don't have any weight. But I do see proton and a neutron. So this is either 1 or 2. What should I put? 1 for the proton or 2 for the proton and the neutron? Now let's just check. I don't mind being wrong. Hey, I'm right. So there's atomic mass is 2 because each of these weighs 1. Now if it has 6, 7, and 6, what is the mass number? Again, protons and neutrons each weigh 1 apiece. So all I have to do is add these up. So 6 plus 7 is 13. If I added the 6, does 6 weigh 1? No, they practically had no mass. All right, I'm going to go with, I'm going to click this every single time. Looks like it. 13 should be the mass. I was right. So if you're wrong, don't worry about it. You just do it again or start over. Remember? Okay, back to atoms. Now it's time for you to do this. And you'll just continue to answer the best you can as you go through. This might take a while, so I believe you can leave and come back to it, and it'll save your progress. Okay? Hope that helps. Let me know if you have more questions.